Hello everyone, I am Siddharthan. In this video, let's discuss how we can deploy large language models as API using Gradio. So Gradio is a very useful tool that helps you deploy LLMs for prototyping. So let's say that you are working with open source models like Gemma, Llama 3, Llama 2 and so on. So some of these models are pretty large, and let's say that you want to host this in Google Collaboratory or even some other environments. So there you can host these and expose these LLMs as API, and let's say you are working on a Streamlit app on your local machine, so you can integrate the Gradio API in your Streamlit app so that you can work with these LLMs hosted in some environment that has the capacity of, let's say, 12 GB GPU or a 15 GB GPU, and you can connect it with your local system that doesn't have like that much of capacity. So this is the application of Gradio, which is mainly to deploy these LLMs as APIs and to integrate them. So in this video, let's clearly understand how we can load this Gemma 2 billion model in Google Collaboratory and expose this as Gradio API. But this process is same if you are working with LLMs like Llama 2, Llama 3, or any models from Hugging Face for that matter. So let's get started. So here I have my Google Collaboratory open and I have connected to a GPU runtime. So here you can go to this runtime and change this runtime to GPU so that your model is loaded in the GPU, such that when you're asking it some questions, so you get a response quickly. So here we have connected it and I've installed three libraries here. So I did a pip install for transformers, which is the Hugging Face library using which we are going to import the tokenizer and the model for Gemma 2 billion instruct model. And then we have this accelerate. So this accelerate is kind of an optimization library that helps us to load the models in a optimized manner in the GPUs. So some machines has like multiple GPUs, so there can be like 8 GPUs. So when you use this accelerate, it makes this process smooth of loading or loading this model in a distributed way across all these GPUs. So accelerate is also required. And then of course we have this Gradio library in order to deploy the LLMS API endpoints. So these are all the three libraries. So here I have already installed these things. So you can do the same as the first step. So for now, I'll just hide these inputs and create a text cell and call these as importing the dependencies. So this is the first step. So first I'm going to import OS library. So this is used in order to access some files, and this is also used to save the API keys in the environment variables. So that's the purpose of this for us. And then I'll say from transformers import auto tokenizer, and so that is the one model that we one module that we need, auto tokenizer and auto model for casual LM. Okay, so this is for the language model. So a lot of pre-trained models are available here. And then we need torch. So PyTorch library, let's import Gradio later. So first let's understand how we can load this Gemma 2 billion and generate some text out of this. And this Gemma is kind of a gated model. So that means you have to accept the terms and conditions, and later you will be having access to this particular model. So you need to accept these conditions, and then we will get the access tokens from the Hugging Face. So this step is not complex at all. So all you have to do is first locate the model that you want to use. So let's say that you are going to use Llama 2 or Llama 3. So you just have to search for that model here. So locate that particular model. So in this case, when we are using Gemma, right? So here you will see a checkbox asking you if you are going to accept the condition. So once you do that, after some time you will receive mail stating that you have been given permission, and you will see something like this. So you have been granted access to this model. So this is all done. Now using this account, we have to get the Hugging Face access token. So for that, go to this top right corner. So this is your profile icon. So once you click there, you will find this settings option. So in that settings option, in the left navigation, go to access token. So here you will see this Hugging Face token. So you can like create a new token or kind of like refresh the previous token that you have. So here I'll copy my token. So if you don't have any tokens, you can always create new token here. So now I'll come back to the code that we have over here. So the next step that we are going to do is save this in our environment variables. So I'll say os.environ, and in square brackets I'm going to say HF token, so all should be in uppercase letter. So when we kind of load this model from auto tokenizer, the tokenizer, and the model from auto model for casual LM, it will look for the Hugging Face tokens in this particular environment variable. So that's why we are passing it over here. So this name shouldn't change, so it should always be in this uppercase letter, and here I'll paste my Hugging Face token. So this is not a recommended way. The best approach would be to save this in a config.json file or in a .env file and load it, so that our tokens and the API keys are not like deliberately present in the code. So that's one thing you probably have to remember, but just for demonstration purpose I'll just like put it over here and I'll run this. So now I'm going to say tokenizer is equal to auto tokenizer, the module that we have imported, and within this brackets, or before that I should say from pre-trained. Okay, some pre-trained, we have to pass the model name. So for this what I'll do is create a variable and say model name is equal to, so that you can copy from Hugging Face. So here you are seeing this right, so Google slash Gemma 2 billion IT, which is the instruct model. So copy it from here and paste it. So this is the name that we are going to use, and paste this model name over here. So here we are going to load the tokenizer for the pre-trained model Google Gemma 2 billion instruct. So let's run this. So this will load the tokenizer in this step. So the next step will be loading the model. So this is the tokenizer for this Gemma 2 billion instruct. Now we have to load the model itself, the LLM itself. So for that we have to say model is equal to auto model for casual LM, and within that we are going to pass some parameters. Again we have to say dot from pre-trained. Okay, so and then I can say here I'll pass the parameter. So the first parameter would be the model name, and the next parameter is torch d type, the torch data type. So let's say that the torch data type is equal to torch dot b float 16. So we are going to make it as like 16-bit values, and then I'll say device map is equal to auto. So you don't have to pass the Hugging Face token because we have already saved it in the environment variables. So let's first understand what we have done here. So here we are using this auto model for casual LM function. So from pre-train we want to pull this particular model. Maybe I'll run this, as this may take some time. So here we are like loading this model, and then we are specifying the data type. So the torch data type. So the data type for the tensors, or basically the weight for the model, is going to be 16-bit floating points. So the reason we are using this is like we have this concept of quantization. So the model's precision, the parameters precision can be reduced so that the size of the model can be reduced. So let's say that for example, right, so here we are using a precision of 16 bit, so the size of the model is 4.95 GB. So if you are using a 4-bit precision, that's going to reduce the model size. So in that case the Gemma 2 billion model will be like 2 GB in size. So if you have smaller GPU, you can use this concept of quantization, so that your model is reduced. Again, you will see a reduced or a decrease in the performance of the model, accuracy of the model, but it's kind of a trade-off that we have to do between the performance of the model and the hardware that we possess. So we have to do this quantization. So here we are doing a 16-bit quantization, so the floating point is going to be 16-bit. So this is kind of a decent number that doesn't kind of reduce the performance by a large factor, but it kind of reduces the size of the model by a fair amount. So here we have done that, and then device map is equal to auto. So this will automatically load the model in the GPU. That means like you don't have to say that I have 4 GPUs, so distribute in a distributed way, load the model in all these 4 GPUs. So you don't have to say that, so it will automatically do that. But in our case it's just a single GPU, so it's not an issue. But if you're using like, let's say, a large instance or easy to instance with like 8 GPUs, 4 GPUs, in that case you can go with this device map of auto. So here, when you open this, here you can see that the GPU RAM is filled with 4.8 gigabytes, right? So that's nothing but the model that we have loaded. So this is the next step, which is loading the tokenizer to this tokenizer variable, and then we are loading the model to the model variable. So now we are all set. So we have the LLM. So the next step is we are going to pass it some text and get a response. So here I'll maybe call this as invoke the LLM, and let's create a variable called as input text, and let's say write a poem about machine learning. So this is what we are asking the model to do. And now we have to pass the model. So we won't pass it directly because the model won't be able to answer it. So we have to convert these into tokens and then pass it to the LLM. So here I'm going to say input IDs. So input IDs is equal to tokenizer input text. So here we just have to say dot to CUDA. Let's understand this. So this is in the form of text, right? So this text will be converted into tokens, which is nothing but it will be chunked into smaller pieces, and we will kind of assign some tokens or like IDs to these texts so that we are passing this numerical values to the model. So that's what happens in the tokenizer, and for this purpose we are loading the tokenizer from this auto tokenizer. Again, each LLM would have like specific tokenizers, and here we are passing the input text which needs to be tokenized, and then return tensors means so all these outputs, so the output that's coming from the tokenizer, so this input text will be converted into tokens and the output format will be PyTorch tensors. So that's what PT means. And then we are moving this to GPU using this CUDA. So that's what this particular line of code does. So it takes in the input text, converts it into tokens, and the output format is going to be PyTorch tensor, and we are moving it from CPU to GPU using this dot to CUDA. Okay, so that will be the next step. So here you can maybe try and print this input IDs. So you have this input IDs, tensors and so on. So this is the data that we have, and then we have this attention mask. So now we can pass this to the model, get a response, and then kind of decode it. So now let's say that our text has been encoded using this tokenizer. So once we get a response from the model, we will later kind of decode it. So here we can say response is equal to model.generate. Here we can say like double asterisk symbol input IDs and max tokens, max new tokens is equal to, let's say we want 512 tokens. Let's understand this. So we are calling this model.generate, and then we are passing this asterisk thing input IDs. So this particular thing, this double asterisk that we have used, right? So this is used to unpack a dictionary. So here we have a dictionary that has this input IDs and attention mask. So we have like two key value pairs. So this unpacks and passes these key value pairs directly. So instead of like passing this as a single dictionary, this will pass input IDs, this tensors, and then like attention mask, tensor value. So this is what it does, and this is the format in which the model expects the data to be as well. And max new tokens basically represents what's the number of tokens that you need in your output from the LLM. So that's the parameter max new tokens purpose. So now we have this response. I've ran this particular cell. So we call this model.generate, pass the input IDs, which is nothing but the tokens that we got from this particular text, and the model has responded to it. Now I can just say response. Let's see how this response is looking like. So here we are not seeing the text, but we are just like seeing some random numbers. This is nothing but the response given by the model is also in the form of tokens. Now we have to decode it. So you can think about this entire process as first you are getting an input text. This input text has been kind of encoded to tokens. We are sending it to the LLM, which is Gemma in this case. So the model tries to understand this and generate the output for this, which is in the form of tokens as well. Now we have to decode this tokens back. So for that we can say output. So let's store this final thing in this variable called as output and say tokenizer dot decode response. You can skip the special tokens if you want. Maybe we can try that. Skip special tokens is equal to true. And finally we can print the output. See, so we have this write a poem about machine learning, machines, they weave a web, and so on. So basically, we got a output. So this is how it works. So we add this tokens as the output, and then we are kind of decoding it. So if you don't include this special skip special tokens, right? So what would happen is, maybe I'll show this to you. Let's remove this. So here you have this BOS, which is beginning of a statement, and EOS, end of statements. So all these special tokens will be removed when you use skip special token. So this is like a good thing to have. So here we are getting the output. So this is the question that we have asked, and then this is the response that we are getting over here. So yeah, so this is how you can load a model from Hugging Face along with the tokenizer and get a response from this. So this is about it. The next main step that we are going to do, which is the purpose of this video, is how we are going to now serve this particular LLM as a API using Gradio. So that will be the next step. So in order to use this Gradio, we need a Python function. So in this case, what we are going to do is, here we have loaded the model, right? And after that, we are passing a input text, doing all those conversion using this tokenizers and decoding this, all those things are present, right? Now we have to put all those things in a function and then later pass this function to the Gradio code. So that will expose that particular function as API. So let's see how we can do that. Let's maybe call this as deploy LLM with Gradio as API. So here I'm going to say uh, import Gradio as gr. I'll also import JSON library. I'll tell you the purpose of this a bit later. Now let's create a function. So we have already installed Gradio library, so that's fine. So here I'll create a function and call this as get response. And the input parameter will be input data, which is going to be a JSON, which is like a preferred data type to send to the model. So here let's say that we have this input data is equal to JSON.loads input data, and then input text is going to be input data. Let's use a key called as query. So I'll explain you about this in a minute. And then we have this tokenizers, input text, and so on. And finally we can say response is equal to so all these are good. And finally return output. So let's understand this function. So this function is going to take a JSON object as an input, right? Because it's better to pass JSON objects in the API. So we are going to do that. So this input data will be a JSON object, and then we are converting this JSON object into a dictionary using this JSON.load method. Okay. So, and then we are extracting this particular query. So let's say that we are passing this as the key will be query, and then we would ask a question like write a poem about machine learning and so on. So we are getting that exact input text and then converting this input text into tokens, getting the PyTorch strings as output, moving it to CUDA, all those steps that we have discussed previously. And then we are passing this to the LLM, getting a response, setting the output size that we want. And finally, we are decoding the response after like skipping the special tokens. And then the output that we are sending is a dictionary that has a key as output, and the value is nothing but the text that is generated by the model. So this is the function. So now we have all the code that we want. So now I can say demo is equal to gr.interface. Gr is nothing but Gradio, the thing that we have imported, and we are going to pass this function is equal to get response, and then inputs is going to be JSON, and the output from this Gradio will also be JSON. Okay, and then I'll say demo.queue dot launch, and within this launch I'm going to say share is equal to true, debug is equal to true, and show errors is equal to true. Let's maybe understand this first. So here we are using this gr.interface, gradio.interface, and here we are passing this function which is get response, and then we have this inputs is equal to JSON and outputs is equal to JSON. So this is telling the Gradio interface that I'm going to send you JSON as input and you're going to send me again JSON as output. So this output will be processed in the part where we are going to invoke this Gradio API thing, and then we have this demo.queue. So actually you can skip this queue, but the thing is when the API is taking more than a minute, right, so it's going to stop invoking that endpoint. So when you're calling a process and you're sure that it's going to take more than 60 seconds or 90 seconds, I'm not very sure about the limit, but you can check that out. So in those cases you can use this queue so that it kind of waits a bit longer for basically this particular code to give you a response, so the model to give you a response. And then we are using this share to kind of generate a URL for our API, the endpoint for it, and debug is equal to true, show is errors is equal to true. So when we kind of pass these parameters, and when there are some issues, we will also kind of display these errors so that it's easier for us to debug. So this is all the things that we want, and now I'll run this. Okay, so got an unexpected keyword, show errors. Okay, so this should be show error without an yes. Let's run this. Hmm. So running on public URL. So this is the URL that you can use. So basically it's like anyone can use this from remote as well. So you can open your PyCharm, run a code in your local and invoke this API as well. So that's doable. So here you can maybe like pass a JSON, get an output, but we are not interested in it, interested in this particular user interface. Rather, we are going to use via API. And here you can see how you can invoke this via JavaScript or even like Bash and so on with curl, basically in the form of this endpoints. But we are interested in Python. Let's say that you are building a Streamlit application and you want to integrate this API with that Streamlit application. Like you can do that. So now all we have to do is, let's say we go here. This is the base codes. We just have to make like slight changes to this. So first we need to install the Gradio client library. So here I'll say pip install Gradio client. So the client version, by the time that I'm making this video, is 1.0.0, so I'll use that, and then I'll import JSON and Gradio client. So I'll say from Gradio underscore client import client. So this C should be in uppercase. Okay, so let's wait for this to complete the installation. So JSON is used in order to convert this dictionary that we are going to create into a JSON object, because that's what our function is also expecting. So here I'll just hide the output and let's run this. So now we have to pass the URL. So okay, I'm getting some issues. Oh, there is a typo. So URL is equal to come to your collab and copy this. Again, it's not like you have to work in collab, so you can also work on your local or any environments. So I'll copy this URL and say input, let's say text is equal to the same question, or even you can like use a different one, or we can directly create a dictionary. I'll say input data is equal to create a dictionary. The key should be query, because that's what we have addressed over here. So the key should be query, and then I'll say what is a LLM, right? And let's convert this to JSON. Input data underscore JSON is equal to JSON dot dumps. So this is the function to convert this dictionary into a JSON object. So let's run this, and then we can pass this URL to the client. So I'll say client is equal to this client with uppercase C, which we have imported, and then pass the URL parameter, the Gradio URL, and run this. So your API will be loaded here. As you can see, you can ignore the warnings for now, so that's not an issue. And finally, we can say result is equal to client dot predict input data JSON. API name is predict input data JSON, which is a JSON object, and then we have this API name as predict. So that is all. Let's run this. So we have successfully called our Gradio API, and now you can just say print a result. So it will be in the form of a dictionary, right? So output this thing. We can check the type whether it's a dictionary or a JSON. It's in the form of dictionary, which is like processed here. And then if you want to get only the output, you can just say print result, and within this you can call this output. Let's run this. So the question is, what is LLM? And it says large language model, or LLM, is a type of AI that has been trained on a massive data set of text and code. Okay, so this is how you can call this API client. So what you can do is put all these things again in a function, and let's say that you are building a streamed tab, and you can call that function in that streamed tab. If you are, let's say, building a chat application or a RAG, right? So retrieval augmented generation. So all this can be done where you're hosting this LLM. So this is, like, as I said, very useful when you are doing a prototype on something and you don't have like this large machines on your PC, right? So, or large GPUs on your PC. So instead you can just use Colab to load the models like Llama 2, Llama 3 and so on with some quantization, and you can deploy this. So even you can follow the same process in SageMaker notebooks that present in AWS, where they offer like this large GPU. So you can do that there as well. So these are the steps. So the only drawback is this share link explains in 72 hours. So they have given this, right? So when you keep this running, so this URL will explain in 72 hours. So here all they have also given this option for permanent hosting, GPU upgrades and so on. And the other alternative for this is, right, so let's say that you have some storage spaces like a S3 bucket or a storage account in Azure. What you can do is, once you generate this URL, you will be able to extract this URL alone. So you can store this URL in a text file, put that in a S3 bucket, and while you're calling this, right, you can load that particular file, load the URL in that file, and you can run this, so that you don't have to replace this particular URL every time that you are running. So this process will be automated. So once we generate a URL with Gradio, so it will be automatically stored in a particular file in S3 or storage account, and here you will automatically call that file and extract that URL from there. So this is like an alternative for this. So this is how you can deploy this LLM as APIs using Gradio. I know that this is a very simple and easy process to do. So please try this out. I'll just give you a quick recap of what we have done. So the first step is installing all the libraries, transformers for loading the tokenizers and the model, accelerate for easier loading of models in a distributed way to the GPU, and then Gradio to deploy it as API. We are importing all the libraries, and the important part of storing the Hugging Face tokens in environment variables, and then specifying the model name and loading the tokenizer as well as the model. And here we have seen how we can give a text, convert it into tokens, and generate the output from the model and decode the token. And how you can basically put all these things in a function and create a Gradio interface and deploy that as API, and you will get a URL, and then you can just simply call this URL using this Gradio client. Again, if you want to use bash, basically curl or even JavaScript, you can follow the code that's present over here. Okay, so that is all from my side for this video. I hope that this is useful to you, and I'll see you in the next upload. Thanks for watching.